So I looked over the first couple of problems, and it looks like A and B are done just great, Maddie. Um, Here's what I would suggest, and I'm going to show you with your B here. I could do it with A as well, but I'll show it with your B because it seems that you understand this pretty well. We just multiply straight across, we look for stuff that cancels, and we get to our simplest form essentially. Okay, so let's look at another option. So I'm going to start right here with this. So you got that 140, and that's not too hard to come up with. You could probably do that right in our head, but 15 times 21 probably had to get out a calculator to get that 315. So what if instead of writing the 140 there, we just leave it as a 14 times 10, and instead of writing 315 there, we just write it as the 15 times 21, right? I don't have to multiply them. I can just write the symbol that means these two things are multiplied. And so I haven't really had to go to my calculator. And then, like in yours, you had 140 over 3, whatever that number was, and you canceled out the tens right away, I think, or divided by whatever you divided by. It doesn't matter. Instead of canceling that stuff out, I could just look at these smaller things, these smaller numbers, and see what factors they have in them. So, for example, the 14 and the 21 both have sevens in them. I can divide them both by 7 or factor out the 7 essentially. I'm thinking of it like, hey, 14, you're 2 times 7. Hey, 21, you're 3 times 7. You both have sevens. And so those sevens just make a 1 or essentially cancel each other out. And you can do that with anything you can find they have in common. So like the 10 and the 15, they both have fives in them, right? So I could cancel the 5 out of 10, making it a 2. I could cancel the 5 out of the 15, making it a 3. And so I've done my canceling before I multiplied. And look at my numerator now. 2 times 2, don't need a calculator for that. And my denominator, 3 times 3. That gave me my 9. Okay, so if we can cancel before we multiply, saves you a little bit of work. So if I'm attacking this problem and it's all multiplication, this number's a little bit hard to make out. I'm going to pretend it's a 5 since I can't read it. And I'll make that a 5 since I can't read it. Call that a 3. Call that a 2. Call that is like an eye test, Maddie. 3, and I'll call that a 2. So depending on your numbers, they may be a different result than I have here. Uh, But here's my top. These all get multiplied, but I'm just going to write it as 4 times 3 times 30. That's the number I'd get. And then my x to the fifth, my y cubed, and my z squared. So there's my numerator. Not multiplied together yet. That's fine. I want to see if stuff cancels. And my denominator would be the 9 times 10. That pen's too big, times 8. Practically glows. Times my z to the fifth, my thing's still too big. Z to the fifth, it's a little better. My x squared and my y cubed. And so now I'm going to look for anything I can cancel before I multiply. So like I start here at the 4 maybe, and let me use a pen that I'm sure is not too big, I hope. I'll start with the 4 and go, hey, 4 and 10. You both have, ooh, I'm going to do the 4 and the 8 because that's bigger. 4 cancels with the 4 and the 8, making the 8 into just a 2. All right, 4 divided by 4 is 1. So this is like a 1 sitting there now, so I can ignore them because 1 times 3 is 3. And 8 divided by the 4 is a 2. So I've canceled the 4 and the 4, leaving me a 2 in that 8. Okay, let's see who else I can cancel. Ooh, this 10, it goes in that 33 times. So I'll cancel that guy out. This 3 cancels the 3 and the 9, but it'd still have a 3 left over. And so now I look at my top and I go, well, you're 1 times 3. So it's 3. And I look at my bottom. Oh, look at that. I could have canceled my threes. I could have done that. It only was going to come out to a 1 over a 2, a 1/2. I don't even need the 1 on top. There's a 1 there, but we'll have variables up there. Let's check our variables now, right? This is 5, this is 2, so they have a difference of 3, and it's 4 on top. Y cubed, they completely cancel each other. And z squared, z5, more on the bottom. How many more? 3 of them. So after canceling out 2 of those, you'd cancel out 2 of those, making that just an exponent of 3. And I don't need to have the 1 there in front of my variable. That's this one here, because we usually don't show ones when they're multipliers. Kind of looks ugly though. X cubed over 2z cubed. That looks a little nicer. Again, you may have to change that answer depending on the variables. But then I didn't have to multiply all these together, right? I didn't have to go 4 times 3 is 12, and 12 times 30 is 360. And then I'd be dealing with a 360, and I would still cancel all this stuff anyway and get to the same answer. Okay, so that works when you got all multiplication. Let's see what these other problems have in store for us. Oh, same idea here, except, oh my goodness, they've given us these polynomials. All right, well, this is where all the factoring work you've done in the past, hopefully, is going to pay off. So each one of these binomials, binomial 2 terms, trinomial 3 terms, is going to have to be factored. Let's see if we can factor these. So the first one, 9x squared minus 16. I check them for a GCF. Is there a number I can pull out of them? Do they both have x's? No, nothing in common. So I analyze and I go, we only got 2 terms. You're squared. Difference of squares, it looks like. And I go, well, I know how that factors. 3x minus 4, 3x plus 4. Maybe you remember that, maybe not, but there it is. I checked my next numerator. They're just going to be multiplied. So I can just put in, ooh, edit a table. I can just put another parenthesis and say, and you're going to get multiplied by, and whatever I factor this to. So these have a GCF, and 8 can come out. So I'm going to bring the 8 out, and I'm going to put them in that parenthesis like that. And then in the other parenthesis, after I take the 8 out, would be divide by 8 would be x plus 1. That's still 8x plus 8 up there if I multiply it, but now it's factored. Then I'm going to factor my denominator. So let's see here. I should have used a different color for each thing. Let's do this one in blue. Checking for a GCF. 12 and 16 both have a 4 in them, so I'm going to take a 4 out. Make this thing a little smaller here. Leaving me 3x plus 4. And then I got this darn trinomial, so I'm going to try and factor him right up here, and then I'll put him down below in the fraction spot. So it's a 3x squared. So the way I do it, I use that Australian method. It's going to take me a little more space than I've allotted for there. So here's my Australian method. I just go 3x and 3x. Just this guy copied down. I figure out what a times c is. That's negative 12. So these two numbers have to multiply to a negative 12, but they have to add up. Negative 12. They have to add up to a negative 1. So 3 times 4. 3 times 4, that multiplies to 12. And if the 4 is negative, the 3 is positive, they'll add up to that negative 1b, that negative 1 that is the b value in the middle. But in the Australian method, after you figure out that, you do have to divide out the 3 that I multiplied in when I was working on that little a times c. And I check to see where can I take him out of. Well, he's in that first term. So here's how that factors. Take out the 3, divide by 3, divide by 3. That gets rid of him. I end up with that factorization. So I put him down here. Hardest part of algebra 2 is being a great factor. Now that it's all factored, I can, just like I could with these numbers, when I could see them, I could just cancel stuff. Well, these now are all factors. And if any of them match, the whole factor matches any factor down here, they cancel out. They make a 1. And you don't have to show a 1 in multiplication. It's got another common factor, 3x plus 4, 3x plus 4. They cancel. Got a 4 on the bottom, and that goes into this 8 2 times. Oh, my x plus 1's cancel. Holy smokes. This comes out to a 2. Everything factored and canceled with something in the denominator. Rarely happens. But that's all there is to all these problems, right? The key is being able to be a good factor, right? If you can get them factored, then you can get them canceled. Let's take a look at each one of these. 3 terms. And so I make 2 sets of parentheses because that's how 3-termed polynomials factor. But this just got an x squared in front, so it's an easy one. These just have to multiply to 12 and add to negative 1. I've already seen that combination. And since I didn't have an a value that wasn't a 1, I don't have to divide anything out. It's just factored that way. Those two things, if I multiply them, give me this. Hopefully this next one goes the same way. That'd be nice. 2 easy ones in a row. It's got an x out front, so it's just x and x to get the x squared. They got to multiply to 15, but add to 2. 3 times 5, they have a difference of 2. I'll make the 5 the positive, the 3 the negative. Yeah, it's not too bad. There's the top factored. Got another three-termer. Starts with an x squared, so it's just x and x. And let's see, multiply to 15, 3 times 5, both of them positive, so they add to the 8. And then, there's that difference of squares again. You see them? 16 is a 4 squared, x squared is an x squared. So this does, you just square root these to figure out what goes in here. 4 minus x, 4 plus x. Now this one's a little bit trickier. You got to watch out for him. See that 4 minus x looks a lot like the x minus 4, just the wrong order. So we're going to have to play with that, see if we can get him to be this guy. But let's see who cancels right out of the gate. X plus 3 cancels x plus 3, x plus 5 cancels x plus 5. All right, I'm going to have an x minus 3 in the top, and I'm going to check this x minus 4 and this 4 minus x. So I'm just going to go to work. So the 4 minus x, I'm going to rewrite as negative x plus 4. I'm going to factor out a negative 1, unmultiply that negative 1, and now it matches. So this x plus 4 can cancel this x plus 4 as long as I have that negative 1 still in my denominator. So there's the top, the x minus 3. The bottom has this negative 1 times this 4 plus x, which I'll write as x plus 4, right? We can add in any order we want to. This negative 1 out here, I'm not really happy with him. I don't know what your teacher's going to want you to do with him. One option is just stick him out front like this. Okay, then he's in no man's land. You could put him on top, but if you put him on top, you have to enclose this in parentheses to say you want the opposite of the top. And so that'd be negative x plus 3 over x plus 4. Don't know what your teacher will want for that thing, but all of those are essentially correct. The same answer. Okay, you get a feel for that, I hope. See here. So these are all the same thing. All right. And so I am going to leave these for you to factor because that's all you got to do is factor them. Okay. And you got to practice that. Okay. Just remember these steps for factoring. Step one, look for a GCF. Step two, if it only has two terms in it, then you're hoping it's like an a squared minus b squared, a difference of two squares. And we just factor it like that. And then step three, there's two types of these. You have the x squareds plus 3x plus 2 type. Those are the easy ones because they're always x and just numbers that multiply to 2 but add to 3. 1 and 2 plus and plus. And then if they don't have a 1 in front, then you have to do that full Australian method. Okay. So again, I don't want to leave you hanging here, but I do want you to practice that. Okay, I'll see if there's anything weird about this. So this one you'd have to use the Australian method for. Your teacher may have shown you a different way to do it, which is fine. However, you learn to factor it. Let me just run you through. So this one, I'll tell you, this would be Australian method. This one, you're going to have to look for a GCF. See, they're both divisible by 12. So you're going to want to pull that out. And ooh, you can also pull out an X. So you want to take a 12X out of both those. Here you want to take a 4x squared, it looks like, out of both of those. Here is going to have to be just a simple factorization. But I'm going to walk you through one Australian method here. So if you ever have a number in front, this works every time. You go, so this is the 2x squared plus 7x minus 4, and here's how you factor them. This, by the way, also works for these, but it's these that you're going to see just much, you don't have to do all the work. Okay, so the first step in the Australian method, when you see this 2 or 3 or 5 or whatever number's out here, if it's a negative number, factor out that negative sign first. But if it's a positive number, just look at it what it is and just put that with an X next to it right in each of these spots. Then multiply these two and get that number, negative 8. 2 times negative 4, right? Negative 8. And so here's now your task. Let's call this number R. Let's call this number S. You just say, hey, I need two numbers that multiply to negative 8. A times C. I also need the two numbers to add up to the B value, the 7. Okay. And when you try to figure this out, you use the multiplications to figure it out. You say, well, it could be a 1 times an 8, a 2 times a 4, and those are the only things that multiply to give me 8. In fact, this is kind of disappointing. 1 and 4, 2, 4, 3, 4, 5. Yeah, that's it. This one doesn't factor, I don't think. Oh, yeah, they do. 1 and 8, sorry. They have to add up to a 7. Now, 1 and 8 don't add up to a 7, but they really have to multiply to -8. So one of these is negative. So I'll make the 8 the positive, the negative on the 1. So now when I add those two numbers, they do come out to 7. So I'd use my multiplication to figure out the A times C value. Make my list, pick the pair that can add up to the B, and then I just put those right in there. I go, okay, one of them's -1, one of them is +8. And then I divide the whole thing by whatever that A value was, in this case 2. Right? Now I'm ready to get to my final factorization. I look at this 2 and say, well, you have to be divided out because my answer doesn't have a 2 in the denominator. And I check the first binomial. Can you divide by 2? No, you can't. I check the second binomial. Can you divide by 2? Yes, you can. So I divide that one by 2, and that makes this a 1x plus a 4. And that is the factorization for that trinomial. It is giving me 7x in the middle of ding-a-ling. Sorry. I was right. 2x squared. This is minus 8x. This is plus 1x minus 4. Everything I told you was absolutely correct. Sorry, I'm sitting in my basement listening for sirens to go off because of our tornado warning. All right, so that's how that one factors. So he's done for you. 2x plus 1 times 2x, oops, times x minus 4. And then you just got to do the same thing to this 12x one, right? Remember how I said showed you pull out the GCF? What's left over? X minus 2. There's your top factored. I'm going to leave it to you to try and factor your denominators. See what cancels. Okay. Same thing down here. I'm going to help you a little bit with this one. I think I would start from this place. You can factor that numerator pretty easy. But down here, I would reverse the order. Notice it's a negative x squared, so when I reverse it, it's a negative x squared still. It's a positive 1, so it's still a positive 1. I wouldn't do anything to the other one, but I would then pull out a negative in this guy down here. So there's my numerator, and I'm going to take that negative sign, factor them out, and it'll change both their signs. And that's going to be a difference of squares at that point, and you'll be able to factor him. Okay. All right, so this guy is going to factor as x minus 1 now, x plus 1. Remember, I said just square root these guys, and it'll tell you how to fill it out. So the square root of x squared is that x. The square root of a 1 is a 1. One of them's x minus 1, one's x plus 1. Right, this one you could do the same way. You go square root that, that'd be a 3x. Square root that, that'd be a minus 1 times a 3x plus 1. Right, it's just always one of them's minus, one's plus. You just got to figure out the numbers by square root those things. All right, factor the top then, and you'll be able to cancel some stuff. Okay, I'm going to jump on to page 2 here now. All right, so this is a classic. Can you take this 24x to the 10th over 2y squared, just 2y, and divided by, this is how you want to write it sideways like this. Don't do like divided by with a fraction or anything. 36, I think that's x squared over y squared. I think so. And so you just got to remember old school for this stuff. It's division. Now we've already done multiplication. We just haven't done division yet. But if you remember back in the old school days, like if you had, let's make it a number you'd know how to do. Say I had 4 and I had to cut it in half, divided by half. That's, by the way, is 8. But here's why it's 8. You don't divide by fractions. You multiply by reciprocals. And now it's just 4 times 2 gives you 8. Some people don't understand how does that give you 8, but you got to understand the question. How many halves are in a 4? Well, there's 8 halves in there. Anyway, so we use this idea of division is multiplying by reciprocal for these problems. We go, oh, I don't know how to do division. I shall change you to the equivalent multiplication problem, right? Just flip over that other fraction. By the way, again, you may have to check my exponents on these. I can't quite read those. But now it's just like problem number one, where I multiply straight across and straight across. And so here's even another shortcut for doing these. I don't really have to even show this multiplication yet. Before I multiply, I could even start my canceling then, right? I don't need to go 2 times 36 and then cancel. I can just go, hey, I got 2 here. He's going to cancel with the 24, making it 12. Let's see, I got, oh my gosh, x squared there. We cancel into that x to the 10th to make it at x to the 8th. This y would cancel one of these y's. Oh, this 12 goes into this 36 3 times. I've canceled so many things I can't keep track, but I got x to the 8th on top, and that's it with this y. X to the 8th with a y next to it. And on the bottom, these all canceled out. Looks like I just have a 3 down there. And I'm thinking I got a variable wrong, right? Or an exponent wrong. Um, because and my numbers are right, so I know it's this one here with the 3 in it. It's denominator. But you are going to have to check the variables to make sure of what those are. All righty. Probably the simplest form. So this is an extension of this one that I left you to work on. So I'll walk through another one of these so you can see it. See, it's a uh, polynomial over a polynomial, so it's a fraction divided by another fraction. So we're just going to change it to multiplication and do the reciprocal again. And then I'll walk you through some factoring once more. So I'm hoping, oh, are those, I think this is an 5x cubed minus a 10x squared. That would make sense. Over 10x, I'm hoping to the fifth. No, I'm hoping to the third maybe, plus 40x. And I'm not going to do divided by, I'm going to say times, and then I'm going to write the reciprocal, right? And now it's a multiplication like that problems on the other page that I left you, plus 6. And we do those just by factoring our numerators. So let's do this guy in purple. Okay. I check for a GCF. 5 comes out of both. I check X's. Hey, I can take 2 X's out because they have this one has 3, this one has 2. I can only take out the lowest number. If I pull out a 5, let's do it in purple. I pull out an X squared, which leaves me with a single X minus 2. Cool. All right, next one. I do this guy. He's a trinomial, and his lead coefficient is just a 1, so it's just x and x. And my R and S, the numbers I put in, they got to multiply to negative 12. So I make a list, 1 and 12, 2 and 6, 3 and 4. They have to add up to the number in front of x, which is a 1. So I'm going to use the 3 and 4. And I'll make the 4 the positive and the 3 the negative. Now they multiply to negative 12, and those two numbers add up to that 1. So it's a minus 3 and a plus 4. There's my numerator, all multiplied out. Denominator, 10 can come out of both, and x can come out of both. So I take a 10x out, leave me with x squared plus 4. Then this is why I'm a little worried. I think that maybe is an x squared. I'll bet it is. I'll bet this guy right there is an x squared. And I bet when I take that x out, it becomes x plus 4. And the reason I'm thinking it's that is because of that x plus 4. That would make it cancel. So I'm treating that like an x squared right there. And I've got one thing left to factor. I gotta factor this guy. See here, his a value is 1 also. He'll be easy. Two numbers that multiply to 6. Let's see here. 1 times 6 or 2 times 3. They got to add up to negative 5. Let's see here, and multiply to 6. Well, if they multiply to a positive number, they're either both negative or both positive. And I want them both to be negative. so they add up to a -5. So I have to use the -2 and a -3. There we go. Now I go to cancel city. Let's see who drops away. X plus 4 is gone. This x would cancel one of these x's. This 5 goes into 10 two times. More 5, or there's a 2 still on the bottom there. X minus 3 goes bye-bye. X minus 1 goes. I don't think there's anybody left on top. I can't just leave it empty though, so it's a 1 on top and 2 on the bottom. Looks like it came out to be a half, if my exponents are correct. Okay, that's the idea. And so this one right here, notice how your x is second. I think I'd reverse this guy. This would be your starting point. You go -18 x plus 24. You're going to pull a negative out of that guy. Over, right? Start factoring as you write stuff down. That's a difference of squares. We just saw him. 3x minus 4, 3x plus 4. And I go times fraction, and I put this one on top, right? Because I got to flip it over because that division I've made into multiplication. So it's 3x squared plus 7x plus 4. Factor him with that Australian method, and then 2x, hard to tell that number. I'm hoping 3 plus 2x. But you'll check for a GCF, then see if you can factor them further. All right, that's the idea. I'm gonna let you do some of that. Same idea here. You're just gonna have to practice these a little bit. Start this one from x squared minus 6x plus 8. Take a 3x. Hard to read these numbers, but I think that might be an x. X4 and x cubed maybe. 3x cubed out of it, giving you x minus 2, I'm hoping, times, and see this goes on top, 2x cubed minus x squared, I think, and the other one then would go on the bottom. And then you got to factor those, all right? So take your time, do things like, oh, it's only got two terms. It better be a difference of squares, right? 2x minus 1, 2x plus 1. Right. Check for a GCF. Oh, an x squared comes out 2x minus 1. Oh, a trinomial, two sets of parentheses, x and x, 2 times 4, negative, negative. So they add up to -6, but multiply to +8. Right. Then start looking for your canceling. All right. Hope that helps. Did do them all this time, but I think you can figure them out. Work on that factoring, because if you can get good at that, these become easy. The faster you are at factoring, which is just working out the multiplications and additions that give you what you started with, um, then